All right, let's dive into what was probably one of the biggest shakeups in programming history, Java 8. Now, I know what you're thinking. Another version update? No. This was so much more than that. This was a full-on revolution that completely changed the way millions of us write code.
And okay, fair question right off the bat. Java 8 came out way back in 2014. I mean, in the tech world, that's basically the Stone Age, right? So why are we talking about it? Well, understanding the why behind Java 8 is absolutely crucial, because this wasn't about just adding a few shiny new features. This was about survival.
So to really get this, we've got to rewind the clock a bit. We need to look at the world back then, a world that was forcing this programming giant to either evolve or, well, become a fossil.
At the time, you couldn't escape Java. It was everywhere. I mean, this thing was a well-designed, object-oriented powerhouse. But the entire world of computing was changing, and Java was seriously in danger of being left in the dust.
Now, I love this analogy from the source material. It talks about a climate change in programming, and it's perfect. Just like in nature, programming languages have to adapt to their environment to survive. And that environment was changing, fast, all because of one massive shift in hardware.
And that shift was the multi-core processor. Suddenly, even your basic laptop had 4 or 6 or even 8 cores. But here was the huge problem. Most Java code was only using one of them. All that incredible processing power was just sitting there doing absolutely nothing. It was totally wasted. Java had to catch up, and fast.
And that really gets us to the heart of the problem. See, the old way of writing Java, it just wasn't built for this new parallel world. Let's actually dig into what that felt like for a developer back then.
Just take a look at this. Before Java 8, this is what you had to write just to filter a list of files. It's something called an anonymous inner class. You're literally creating a whole little mini class just to pass one tiny piece of logic, that is hidden check, into a method. Your actual goal gets completely buried in all this boilerplate. It's clunky, it's hard to read, and as the source material puts it, yuck.
So what was the old fix for trying to use all those cores? You had to do manual multi-threading, and this quote just says it all. It was a total minefield, notoriously complex and a breeding ground for bugs. Trying to manage threads and locks and share data, it was a nightmare that even the most senior developers struggled with. So, yeah, something had to change, and Java 8 delivered. But it wasn't just a new set of tools. It was a complete paradigm shift, a totally new way to think about writing code.
The absolute heart of this whole revolution is this idea of first-class functions. Think about it. We pass values like numbers and strings and objects around all the time, right? Well, Java 8 finally let us treat a chunk of code, a function, as just another value you can pass around. We often call these little anonymous functions lambdas, and they're the key that unlocks a whole new functional style of programming.
And that's the big idea, right? Behavior parameterization. Instead of just passing data to a method, you can now pass the action you want that method to perform on the data. This just opens up a whole world of flexibility.
And boom, look at the result. Remember all that clunky anonymous class code from before? Compare it to this. All we're saying here is, hey, sort this inventory by comparing the weight. We're passing the getWeight method itself directly. It's called a method reference. It's clean, it's concise, and it reads just like you describe the problem out loud.
Okay, so once you can pass behavior around like that, what can you build with it? Well, you can build some incredibly powerful stuff. And the absolute crown jewel of Java 8 is the Streams API, which takes this new functional thinking and applies it to processing data.
The best way to get your head around streams is this Unix pipeline analogy. You've got a source of data over here, and it just flows through this series of operations. Each step in the pipeline takes the stream, does something to it, and passes it along to the next. It's a super high-level, declarative way to think about data processing.
This also brings up another huge mental shift, from external to internal iteration. Before Java 8, you wrote the for loop. You had to manage every single step. That's external iteration. With streams, you just declare what you want done, filter this, sort that, map this, and you let the library handle the how. That's internal iteration, and believe me, it is the secret sauce to everything that comes next. To really see the difference, just look at this mess. This is pre-Java 8 code. The task is simple. Take a list of transactions and group them by currency. But the code? It's a maze. It's got nested loops, if statements, you're manually creating maps. It's so hard to read and even harder to change without breaking something. And now, look at this. This is the same logic, but with streams. It's a beautiful, clean pipeline. You can literally read it like a sentence. Take the transactions, make a stream, and then collect them by grouping by their currency. It's not just that it's shorter, it's a profoundly better way to express what you're trying to do.
And now we get to the ultimate payoff. Remember all those CPU cores just sitting around doing nothing? Well, that idea of internal iteration, letting the library handle the how, is the key that finally unlocks them.
The source material has this amazing quote that just nails it. Parallelism almost for free. Because the library is in control of the iteration, it can make really smart decisions for you, including the decision to run your code in parallel.
So how does it work? Well, it's pretty clever. The Streams library can automatically split your data up into chunks. Send those chunks off to be processed on different CPU cores all at the same time, and then seamlessly join the results back together at the end. All that nightmarish thread management we talked about, it's just handled for you. Now, of course, there's a catch. There's always a catch. To get this free parallelism, the behavior you pass to the stream has to be stateless. That just means it can't rely on or change some shared variable somewhere. And why is that? Well, if you have multiple threads all trying to change the same thing at the same time, you get chaos. So this rule really pushes you to write in that clean, functional, side effect-free style. It's the price of admission for simple, safe parallelism.
So let's wrap this all up. When you look at the whole picture, Java 8 was so much more than an update. It was a massive course correction that really pushed Java, and all of us who use it, into a more functional future.
So what's the legacy? Well, we moved from imperative code that tells the computer how to do every little thing to declarative code that just says what we want. We went from that verbose, clunky boilerplate to clean, concise syntax. And, maybe most importantly, we went from difficult, error-prone manual threading to simple, powerful parallelism, all by embracing this functional style of thinking.
In the end, programming languages have to evolve. They have to adapt to new hardware and new problems, or they die. Java 8 was a masterclass in adaptation. It saw the multi-core future coming, and it remade itself to meet that future. Which kind of leaves us with one final thought. The language evolved, how will you?